Okay, let's go over homework 3.4, number 5. Right, so we are looking at the solid with a square base. So it should look something like this. So you have a square base. So you have a box kind of like this, and it has a square base. Right, so you can't see this, and you cannot see this, and like that. Right, so let's call the side of the base x by x, and maybe height is y. Right, so we have top base and top and bottom base. So each one has an area of x squared, x times x. So the surface area A is 2 times x squared. Right, so that's top and bottom. Right, so that takes care of the top and the bottom. All right, then the side wall, there are actually 4 of them. There's 1 here, and 2, and 3, and 4. Right, and so there are 4 of them, and each one has an area of x times y, so 4xy. Right, and this area is surface area is fixed at 433.5, so not a very nice number. All right, so from here we have a way to express y in terms of x. So let's do that. So basically solve this equation for y. So subtract 2x squared from both sides. You get 4xy is equal to 433.5 minus 2x squared. Right? Then we can just divide through by 4x. So y is equal to let's see, I'll just write it as 1 over 4x times quantity 433.5 minus 2x squared. Right, so that's y. All right, then we want to, let's see, maximize the volume. Volume is easy to find. It's going to be x times y. So volume V is going to be x squared times y. Right? So since we can replace y by this guy, so you're going to have x squared times y is this guy right here. Right? So it's a 1 over 4x and quantity 433.5 minus 2x squared. All right, so you can cancel x here and one of the x here. So I'm gonna just distribute this x to both sides, both terms. Right, so you end up getting let's see, 1/4. I'll just keep it outside. Then you will have a quantity of 433.5x minus 2x cubed. All right, so let's find a critical number by taking a derivative. So this is a function of x, so volume function depends on just x. So v prime of x is going to be, all right, so 1/4 is just a constant multiple, so put it outside. Right, derivative of 433.5x is going to be just a 433.5, right? Then derivative of negative 2x cubed is negative, let's see, 2 times 3 is 6. X to the, subtract 1 from the power, so squared. right? So we have that. Then we set that equal to 0, right? Then we can multiply both sides by 4, which well, we get 433.5 minus 6x squared is equal to 0. So we multiply both sides by 4. All right, then add 6x squared to both sides. You get the 433.5 is equal to 6x squared, right? Then we can just divide through by 6 to get the 433.5 divided by 6 is equal to x squared, right? Then we're going to take the square root of both sides to get, all right, I'm going to cheat a little bit. Let's see. So I'm going to erase that. All right, so let's take 433.5 and divide by 6. You get that. Then I'll take the square root of that. So it's 8.5. So x is going to be, so it's a plus or minus 8.5. All right, but since x is the length of one of the sides of the base, so we don't consider the negative one, so it's going to be positive. 8.5 is the critical number, right? Let's just make sure that it gives you the maximum volume by looking at the sign of the derivative. So let's do a number line here. All right, so x is it has to be a positive number, so 0. Then a critical number happened to be 8.5. Right? Then we can just try anything smaller than 8.5. So maybe not f, sorry. It's a v prime of 1. All right? So you can see that the b prime of 1, if you plug in 1 here, so 433.5 minus 6, which is definitely positive. All right? So v prime. So v prime is positive on that interval. How about after 8.5? So we can try v prime of 10 or something like that. And you can see that the 433.5 minus 2 times 10 square, actually 6 times, I was looking at the wrong thing here. 433.5 minus 6 times 10 squared would be 600, so that would be negative. So we have a negative sign here. So v prime is negative when x is greater than 8.5. All right, so you can see that the volume function is increasing between 0 and 8.5, and after that it's just to keep on decreasing. So we can see that at the critical number 8.5 you will have a maximum. All right, so we know that the x is 8.5, and which is the answer, the right answer. And we can find the y value by using this formula right here. All right, just to plug it in. So y is equal to, let's see, 1 over 4 times 8.5 and times 433.5 minus 2 times 8.5 squared. All right, I'm going to cheat to get that value. So here, all right, so I'm going to do, first I'm going to just compute the expression inside the parentheses. 433.5 minus 2 times, let's see, 8.5 squared, that's a square. Sorry, I'm going to redo this one. All right, so let's see. I'm going to just all right. So 433.5 minus 2 times, right, 8.5 squared. Did I put that's the square? Okay, and then get the value divided by 4 divided by 8.5. Sorry it took so long. All right, this came out to be 8.5 as well. All right, so this is 8.5. Right? So the volume is easy once you know that the y and x, it's actually, so volume is x squared times y, but x and y are 8.5, so all you have to do is volume is 8.5 squared times 8.5, so which is 8.5 cubed. So if you do that, let's see, oops. Let's see, right, 8.5 raise it to the third power, right? So you have 614.125. So 614.125 is the volume, which is the right answer. All right, that's it. I hope that this was clear.